Welcome to Ants Are Everywhere. We're taking a look at some source code. As always, we're looking at Kythe, which I was calling a language server in my head for a while, but I think is more of an indexer. In fact, I think it might work with LSP to do the serving. We've looked at several projects at this point that are in the domain of understanding source code, serving you up information about source code. We've looked at some LSP, language server protocol implementations. We might have looked at the API itself. I frankly can't remember. You can search for LSP on the channel. We've looked at Visual Studio Code, I believe. We've looked at SourceGraph from back when SourceGraph was still open source. And we've looked at Bazel, which is a build system, but it, I think among other things, will generate information about your code. And it also has some cool source code searching functionality for sourcing the dependency graph of your code. And last week we looked at Aider. And Aider is a vibe coding LLM assistant pair programming thing that's open source that you can plug into usually a non-open source LLM to help you write code. And one of the things that I noticed when I was looking at Aider is that for my own personal needs, it wasn't really giving the LLM the kind of information I would want it to have in order to be able to efficiently solve problems. And so that's why I wanted to look at Kythe to see if it is possibly going to make it easier for me to expose information to the LLM. There are other ways to do these sorts of things. I'm sure there are rags out there that build information about your source code. I think git ingest is a thing that people have used, but git ingest seems pretty basic, and I think Kythe is going to give more of the graph-friendly, queryable sort of information that you would want an LLM to have to answer questions like, what are all files impacted by this file? What are all files that you might have to test if you change this thing? And one thing that, for example, most LSP servers won't do, maybe no LSP servers do, I don't know, is search across languages. So if you have like an API definition in a language agnostic descriptor language, and then you generate bindings in, say, Python and Rust, most LSP programs won't let you search for from the Python code to the corresponding Rust code for dealing with that object. So that's all information that an LLM should have if it wants to, for example, change those definitions. And I think that's the sort of thing that Kythe will provide. So I figured it was good to take a look at it. So a lot of these commits are older, but some of them are not so old. 2 days ago, add an extractor. Okay, so I was a little bit nervous when I chose Kythe that this might be a dead project, but it doesn't seem to be dead. So we'll see. Is my audio going through? Yeah. Okay. For a second, it looked like the bouncy thing wasn't bouncing. Okay, so Kythe, this is, I think, just basically a Google project. It seems to be mostly Go. Well, equal parts Golang and C++. There's some Java, Starlark, probably mainly for the build files, some TypeScript. For what? I don't know. Some of this will be for understanding the corresponding language. I imagine Java and C++ are mostly for understanding the C++ and Java ecosystems. And I'm going to just go out on a limb that most of the kind of what you would call business logic, most of the functionality is written in Go. Although we'll see. And then I have no idea what TypeScript is used for. It might be used for understanding TypeScript. There might be some sort of front end. Shell is probably for utilities and build scripts and stuff like that. Although, surely most of the build stuff is in Go. Okay. Just for fun, what is the license? It has to be some open source business friendly license, Apache 2.0. And they have a website. Maybe TypeScript is just for the website. It's kind of bare bones. I don't know if it looks any better color-wise if I turn off Dark Reader. It's an open question. And we can see the Kythe schema. It has indexer implementations for C++ and Java. I guess that leaves out Python. And it has compilation extractors. I don't know what a compilation extractor is in general, but I'm going to guess that it's something that extracts useful information about your code from compilers. And it has a verifier for indexers and some cross-reference service. And we have some examples in some community. Usually I don't look at the documentation at all, but maybe I will a little bit this time since I plan to use this in the near future. Should we look at examples? So we can index the Kythe repository, so we call Bazel build on some released Docker image. And there's something about graph store. There's architecturally, how do we expect this to look? Basically, they're going to build some sort of graph. I think it's probably a fairly simple graph. What is in the graph? I don't know, but probably all sorts of source code relevant information, among other things. What file imports which file? If you're using an identifier, where is that identifier defined? Where else is that identifier used? And in a source code aware way. So if I have a widget called default and a string called default, Kythe should be aware that those two things are different types and that a reference to the default string is not a reference to the widget default. Extracting other Bazel-based repositories. Bazel, okay, so we have some Bazel RC, and it has, I guess Kythe has its own Bazel, like our configuration file, maybe? And it's going to tell Bazel how to build stuff. I'm curious now about what a compiler extractor is. I want to know if it's a general thing or if it's just something they talk about. Bazel compile commands extractor, invoking API extractor. Let's look in Wikipedia. No, okay. So, and then we have what an indexer verification is intended for a source language agnostic. A standalone component that checks that a database of Kythe artifacts supports a set of goals. So, like well-formatted list, all Vnames must have at least one field set. Facts must be one of the following forms. It looks like they're storing basically, I was going to say triples, but these are quadruples. So triples are a common way to store things in logic databases. They are basically just a description of a graph structure. These are quadruples. So we have source edge, whatever target is, possibly a root directory, and maybe like a label or a type, and specifying goals. Okay. So let's look into it. I don't even know basic things like, for example, what satisfies. I don't know what kind of database it uses or any of that. So I'm going to keep the documentation open in the background. I'm going to open this. Kythe is probably where all the stuff is. We do have a Bazel CI config. I think Bazel CI is like a private hosted Bazel service, or maybe not. Build Kythe. Yeah, so I think build Kythe is maybe the hosting thing. Move beyond CI/CD with build Kythe scale out delivery platform from 2013. I don't know if it's related to Google at all, or if it's just some thing that they're using. Okay, so this is just some pre-submit config that will just build everything and test everything after installing some stuff on Ubuntu. And all the Nix people will be shocked and horrified that we're installing Ubuntu and calling apt-get, but that's how things work sometimes in the real world, man. I don't know what to tell you. So the Go directory is probably important. Oh, camel. I kind of doubt OCaml is being used to support like Kythe information of OCaml, although maybe it is. I'm wondering if maybe OCaml is used for kind of like a logic programming. I don't know, TypeScript. I'm gonna guess is largely the sites, although web/site is probably the website, and some doxy file and some build file, which is sometimes useful. Did I open proto? I did open proto. CXX should be C++ and C, and then the extractors. And what if I just ignore Java? I'll open it, but maybe I can ignore it. Okay, so in OCaml, we just have this JS indexer. Dump Kythe the command.ml and flow.patch. I don't know what a .patch file is. It's just a patch? Okay. So they're patching some third-party flow source code. Is this something that they have? Do they have their own third-party directory? Yeah, okay. So they're using OCaml, I guess, to understand JavaScript. And I don't know why, but, or maybe this is a verifier. No, it's an indexer, it says, but it says let fact node, fact name, fact val. So, I don't know OCaml, but I'm guessing node is the first thing, fact name is the second thing. Where's our documentation? Okay, this is what I was trying to find. So we have the source edge target, and then what seems to be a path, and then just a general string. And I'm wondering if that's the same thing that we're seeing here. Get rid of this pre-submit. Here we have a fact is a node, a fact name. Doesn't seem to be the same. And a fact value. So for example, whatever node is, the empty string, none, Kythe, and then this combinator, maybe this is like concatenation, string concatenation, and then a fact value. And here seems to be closer to what we were looking at. We have an edge, a source, and an edge name, and so on. And then we're just building stuff up in OCaml. And it seems like we're mainly working with facts, which does seem to be related to logic programming, but I'm not sure in particular what we are doing. I did see this time that we have a description of the Kythe storage model, which I will add to Wallabag. The persistent storage representation for the Kythe analysis data is to permit the Kythe data to be stored in a compact and portable way. This is a storage representation in contrast to serving representations. Okay, and so you can read about this, but I'm not sure that they're using like an existing database. Maybe they're just like storing in custom files, which would be a very Google thing to do. Level DB is also a very Google thing to use. Okay, let's move this. Maybe we can move this to its own workspace. How about workspace 3, since 2 is where the AIs live? Okay, this is from before, some previous stream. And where are we? That's Emacs. All right, get rid of Emacs. Get rid of this thing. Is this the only browser window I have open? Okay, huh. I don't know if I just lost my place, but you never know. Okay, so where was I? I wanted to be in Go, and that's here. So move Go. I thought I had moved Go to its own window, but I think I didn't yet. Okay, so we have, what else do we have? We have Proto, TypeScript, etc. So let's get rid of TypeScript as soon as we can. We have Browse. And Browse seems to be a bash script. That's, I guess, starting some HTTP server, serving tables. Okay, so this is some server. I guess we'll ignore this for now. This is the site, we'll ignore it. This is whatever a doxy file is. I think it's the documentation thing for doxygen. Okay. And here's the build file, which is not so informative. We're just grouping all the things. And this seems to be mainly for the website. and making protos visible. So this is just the root one, so maybe that's not so fascinating. And here's CXX. And here's more extractors. Extractors, we have Bazel, GCP, OpenJDK 11. I don't know what GCP is for, though. Examples. gcloud build submit. I guess this is, I don't think this is an extractor for GCP. I think this is an example of how to use cloud build artifacts, I guess, maybe in your, to extract things, kind of to make it easier to onboard people to using GCP as the kind of source of their cloud stuff. I'm not sure. But it seems like we can mostly ignore that. And that brings us to the Go stuff. So we have indexer language server, which I'm going to guess is possibly at this point LSP based or maybe will be. Local run, I don't know. Platform is probably not so important, but I'll open it. Services, serving, storage, test, and util. Did we have extractors here? Yeah, extractors. So let's start with extractors. We have Bazel command, config constants, GCP config, golang, govname, and proto. Let's start with Bazel. I don't know what command is. It could be basically anything. Config constants, golang, I guess we'll look at whatever govname is in proto. So Bazel, you've got xutil tree set, some settings, some extractors, which is in the Bazel like Starlark language, I guess. Or maybe that's just a config file. I don't remember what .bzl files are. And utils and settings. And then tree set and xutil. I'm not sure what extractor util, maybe, probably. And then we'll look at the extractor go and also the Bazel file. Let's start with the Bazel file. Copyright 2017. We have a kzip extractor. Rules for kzip extraction. I don't know what kzip is. Is this a general zip thing or is this a Kythe thing? Fitness accessories. Kythe compilation zip format. So this seems to be a Kythe thing. This document specifies a compact persistent storage representation for compilation records suitable for use by Kythe to generate cross-reference data. Okay. All right. So this is a macro to handle kzip stuff. Presumably you just call some other utility. I'll just scroll through this. We have some command prefix, and then looks like it's building up a shell command. They've got this native action listener thing and something about regular expressions. Okay. I'm just going to mainly ignore that. The extractor test. Sometimes tests can be useful if you're dealing with something complicated like this, but this is not so long. I see things like kzip scan. That's presumably looking into the compressed file and maybe checking for values related to some proto. I'm seeing extraction and stuff. Okay. Fine. And then here's the extractor.go. And how big is it? 383 lines of code. This is a config. A config carries settings that control the extraction process. Okay. So you have check action, check input. I think action just means like Bazel action. Probably same for input. And is source, fix up, open, read. Probably open a file for reading and then extract to kzip and extract a file. Infer corpus. Let's try check action. So check action is a thing that takes a context, which is very Google-like, some info, which is some action info thing, and it's done on a config, and it, I guess, returns an error. It's not this. And if check, so we're going to call C to check action. C is what? This thing, this function. And if check is, and that's going to give us a thing called check, and if it's non-nil, we're going to return check of the context and info. And this is check action with an uppercase. So let's go there. That's the like exported version. If set, this function checks whether the given spawn action should be further processed. If it returns an error, the action will be rejected. Otherwise, all actions will be processed. This function may modify its argument, and such changes will be preserved. So I'm wondering if this is just like a part of the config that is allows you to exclude stuff, like exclude certain actions. And then here we're going to call check. This is maybe more meaty. This is now part of the indexer rather than the extractor. And check, I guess, takes an error. Maybe this is not meaty. And sorry, it's part of an emitter. It takes an error as an argument. And I guess it sets the first error and logs some stuff. This is just kind of like an error handling logging utility. Fine. But I don't understand it where any of the behavior is so far. So is there anything else that has behavior? So extract maybe? Extracts a compilation from the specified extra action info. So you pass in an action info, a file reader, and it returns some compilation unit. APB, I'm not sure what that is, and an error. And it's going to log some stuff. We're going to call check action, I guess, to make sure that we are supposed to look at this thing. And if we don't have a corpus already, we'll try to infer the corpus based on the info. And then we'll construct the basic compilation unit using whatever APB is again, with the language and stuff in corpus, I guess, that coming from the config. And we're going to record the arguments. And we'll capture the primary output path. Although the action has room for multiple outputs, we expect only one to be set in practice. It's harmless if there are more, though, so don't fail on that. Okay, so we're going to record some outputs, just looking to the first one, the 0th. We will capture the environment variable, and then capture the build system details, just some stuff from Bazel. Load and populate file contents and required inputs. First, scan the inputs and filter out which ones we actually want to keep by path inspection, then load the contents concurrently. Okay, so we're going to load a bunch of files. Some we might exclude. And I guess we're going to time stuff. So we're setting the time to now. We'll call fetch inputs. I guess inputs probably are possibly or almost certainly remote, at least in Google's environment. And whatever fixup is, some fixup stuff. And then we're going to log the info context and return CU, which I guess is the compilation unit. So what does fetch inputs do? If there's an error, I guess we return some file information. If error is not nil, we return this. No. I think that this is what happens if we don't error out, right? We're calling the hang on. This is defining a function. This is part of a function definition. So where's this closed? So this function thing is opened here. It's closed here. So where is c.fetch inputs closed? Here. Okay. So this is I got confused by the way this was formatted. Okay. So this is doing some fetch input stuff with what looks like essentially a callback that does some error handling, and then ultimately it seems like we return the compilation unit. But where does that come from? It seems like a lot of the compilation style work is being done by APB. Let's see if we can find out what APB is. An all points bulletin. APB is the analysis go proto. Okay, so that's just some proto. Okay. So this is constructing the compilation unit. And where do we actually... So fetch inputs is going to do some stuff. So far, I think we're not actually compiling anything, although maybe we're... Where is compiler stuff being done? Maybe compiler is already run. We do have classify inputs. Am I looking at the same function I was before? I'm not sure. This is extract right now. Load and populate file contents and required inputs. First, scan the inputs and filter out which ones. We saw that. Whatever classify inputs is, that might be a pretty simple function. Classify inputs updates the unit to add required inputs for each matching path and to identify source inputs according to the rules of C. C is what? The language or the config? The config. The filtered complete list of inputs paths is returned. So we've got this tree set thing. We're expanding directories for the inputs. We're checking the inputs. And we're going to try to add them if they're not already there. And if it's a source path, we're going to add the path to the source files. And then we're going to try to apply some rules. In getting a Vname. V stands for what? I don't know. And so on. And tree set, etc., etc. So tree set is maybe, I thought that was going to be cool, but maybe it's just like a set for, like a container. Tree set. Package tree set provides functions for extracting targets that use Bazel tree sets. So maybe it is cool. What is a Bazel tree set? We have a Merkle tree. There's a tree set Java thing, tree artifacts, and transient files. Constructs a Merkle tree from lexicographically sorted map of inputs. What? I think a Merkle tree is necessarily a hash tree. The Java tree set is probably just a container. So a tree set in Java is an implementation of the sorted set interface that uses a tree data structure for storage. And it ensures that things are always sorted. Okay, cool. And under remote Merkle tree, we have a directory tree. This is the Bazel source code now. An intermediate tree representation of a list of lexicographically sorted list of files in the tree represents either a directory or a file. Wait, what? I'm missing some words here. Each node in the tree. Okay. So we do have a hash code. And where does the Merkleness fit in? Nowhere. Merkle tree. Directory tree builder, Merkle tree. Let's try directory tree builder. We got lots of stuff. Build from action inputs. Visits a code and adds file node to blah, blah, blah. And where does Merkle fit in here? Is there hashing? You have a hash map. Maybe I'm misunderstanding what a Merkle tree is. A Merkle tree is a hash tree or a Merkle tree is a tree in which every leaf node is labeled with the cryptographic hash of a data block. So I'm assuming that what they're doing is they're just hashing the files and using that as the identifier. But it's not completely obvious. How Bazel works. Verifying your browser. Come on. The whole build graph is in fact a Merkle tree, and that would be correct. So they're doing something with Merkle trees. And I think that it's just hashing. So it's kind of like content addressable or whatever. Okay, so I think that's what's going on. And then this tree set stuff in Kythe is for understanding Bazel's tree sets. And this is building stuff up. But I don't really understand what's really Bazel-y here, but we'll move on and see if we see some other stuff that's cool. Tree set xutil. Did we look at xutil? We have xutil.go. This is extract and write. Extracts a spawn action through C and writes the results to the specified output file. Okay. Okay. Whatever command is. Maybe this is just like command line tools for Go. I'm going to guess that's what this is. Kzip writers, etc. Seems maybe command line-y. We do have some Rust stuff. I don't know what that's about. Extractors, we have golang.go. Oh, sorry I missed you, Emerald. I must have had you below the line of vision there. Thank you so much for doing this, says Emerald. Thank you. Thank you for joining me in doing this. Okay, so what do we have in Golang? We have init. We're going to get the working directory, and that's basically it. I don't know what a vname is still. It's probably, maybe it's in the documentation. I mean, it can't be too mysterious. It's like the name of something, some useful part of Kythe. I don't know what else there is to say about that. Where's the documentation? Did I close it? I didn't think I did, but you never know. Yeah, sorry. I use like 16 different window managers. I need to clean up. I need to simplify here. But that key combination wasn't doing what I wanted it to. All right. So, you know what? Did I move it to 3? Maybe? Okay. We do have vnames here. I don't know where they are defined. About Kythe vname. Anchor vnames. var name? Maybe vname is a general thing. I'm going to guess variable name. Okay, so an extractor is a type that is some struct. It has a build context, some packages, some package vname options. I feel like it's not. Let's ask DeepSeek. In Kythe, what is a vname? We probably don't need DeepSeek for this. Version name is a structured identifier used to uniquely reference an entity, like variable, function, class, etc., in a code base. Oh, it's a proto message. Defined in Kythe schema and consists of several fields that help disambiguate entities across different contexts. So a signature, a unique string to identify the entity within its scope, a corpus, a root, a path, and a language. But how is it versioned? Okay. Versioning is implicitly handled by the corpus and root fields. So you say. It's probably worth going to the proto, but for now we'll just assume that's kind of right about vnames. It seems like the basic, maybe kind of like the basic information unit. And we've got options, alt, installation path for compiled packages, etc. You can add a package, presumably a Go package. I don't know what else we would be doing. Then we've got this, whatever E is, E build context import. E is the extractor. Okay, map package, vname for, etc. Directory to import, locate. So we have this extract function which returns an error. Extract populates the units field of P and reports an error if any occurred. Okay, so we're going to call this vname for the build package. Whatever gov name is, we're going to get the repo root passing in the path of P. We'll also get the corpus root somehow. We're going to create a compilation unit, which is some proto message, giving it the vname in the argument. And marshal any is like a protobuf thing that's going to, I guess, like marshal in any proto, which is like a free-form proto that you don't have to know it like compile time what the kind of proto it is. Giving it some Go details, like the Go path, goos, Go OS, Go Arch, compiler, and so on. And a bunch of other stuff, add source. So we're building stuff up. I still feel like I don't understand like where any of the compiler specific stuff is visible. Figure out whether we should emit separate compilations for CGO actions. So we're going to add a flag. CU should be the compilation unit. We're passing the compiler, and somehow a compiler comes from here. And this is all tags. And I don't know what that is. Here's fetch. Fetch implements an analysis fetcher interface. Okay. Add input and so on. This looks like it's maybe doing more stuff than the Bazel one. Govname.go. I don't know what govname is. Package govname supports the creation of a vname protobuf messages for Go packages and other entities. Govname is Go vname, not govname. Okay, whatever. So here's one proto. I guess it's the extract proto kzip. This is probably not the most informative one, but maybe it is. So we've got some variables. Oh no, this is a Go. This is a Go file. I was gonna say I didn't know you could do this in proto. So this is some Go file for handling protos. What I want to see at this point is now like the actual proto definition, which is frankly where I probably should have started. Oh, this is the same folder. So let's go back. Here's indexer. Indexer. So extractor, I still don't understand, but it's extract some stuff. The indexer should now just be about indexing some stuff. What is it going to do? It might well, once you have the graph structure, that's essentially an index, but it's probably going to do other things, like do like a trigram based search thing is kind of like one of the classical things to do, where you're now like building a reverse index based on like smaller string identifiers. So we'll look at the indexer, I think, but we'll look at that maybe more at the end. Language server. I guess we'll look at it quickly just since we're coming upon it. I hope that it's LSP implementation. Okay, so package language server provides an implementation of the language server protocol. The server implements the following capabilities: text, document sync, full, and reference provider. And it's written in Go, but I don't know if that means that it's only serving Go LSP stuff. I am going to get, first of all, they're importing source graph. Source graph is like an open source clone of Google's internal code search. But I'm going to guess that this language server is really serving across all of the languages, but I don't know. So server provides a language server for interacting with data in a Kythe index. So you have a struct that has some workspaces and some local file document, etc. And xrefs are the cross references and some options. And some page size, which is maybe the size of like results to return. The number of cross references the server will request by default. Okay, so I think that this is serving the entire stuff. We've looked at language servers before, so we won't belabor this point. Platform. Platform is maybe like stuff you need to host Kythe or something. So we have analysis, cache, delimited, and kzip. Let's move this into its own thing. Analysis, cache. I don't know what delimited is. We'll look at delimited first, maybe. Delimited.go and dedupe. Package delimited implements a reader and writer for simple streams of length delimited byte records. Okay. So it's a record that knows how long it is. Each record is written as a varint encoded length in bytes, followed immediately by the record itself. That's how protobufs kind of works, I think, on the wire. I don't know if they're reading protobufs, though, or something else. Okay, so that's what delimited is. KCD is what? Defines the interface and utility functions for the implementation of the Kythe compilation database. So maybe this is like a main entry point. Reader represents read-only access to the underlying storage layer used to implement a compilation database. So we've got some reader, and it's got some storage layer, which I think we believe is level DB based. Compile compiles the filter into a matching function that reports whether its argument matches the original filter. So this is some sort of search stuff. So that's kind of cool, but I'm not there yet. So kzip should be just support for whatever this kzip file format is. You can scan the compilation records and the zip file and so on. Presumably they don't implement their own compression algorithm, or maybe they do. We're importing archive/zip. And I think that probably whatever archive.zip is that's probably the thing that's ultimately implementing compression. And analysis has what? Things like a proxy, a driver, and some local stuff. Proxy.go. I'm guessing this is just a proxy. Okay, package proxy implements a wrapper that provides an analysis request that proxies an analysis request to a Kythe indexer that does not speak protocol buffers or RPCs. Communication with the underlying indexer is via JSON over pipes, with messages from the proxy to the indexer on one side and replies to the other. Each JSON message is sent. Okay, so this is why. This is maybe here for non-Googlers who don't want to use protobufs and gRPC, and they want to use JSON and WebSockets or something. I've thought about doing this for other things, but okay. I'm going to guess that that's what this is, but I'm not sure. Driver is what? Package driver contains a driver implementation that sends analyses to a compilation analyzer based on a queue of compilations. A compilation represents a compilation and other metadata needed to analyze it. So we've got some compilation unit, a revisionist string, and a build ID. And I guess the thing will have to look up the build ID. This is like essentially like a UUID reference to the thing that's actually compiled. Like the I don't know, whatever GitHub Actions probably has some sort of UUID for each compilation or each run. Here's the run function. Run sends each compilation received from the driver's queue to the driver's analyzer. And I think that this is probably pretty freeform. Like you're just handing off this information and the analyzer is responsible for knowing how to deal with it. In analysis.go, analyze calls F on each analysis output resulting from the analysis of the given compilation unit. Entry output fetcher. Okay, this looks pretty generic. KCD, I think I maybe wanted to look at later. Analysis, I feel like I maybe have a handle on. And that's most of platform, but where I really wanted to go is the protos. Are we ready for protos yet? We have services, graph, graph store, file tree, explorer, and CLI, and link web and xrefs. I think we know what all of this will do. Serving has an API and a graph and a pipeline, and storage. As an entry set, GSUtil should be for like using Google Cloud buckets, kind of like their version of AWS S3. in memory. This is probably some in-memory store, a key value store, level DB store. Seems like you can maybe use different backends for storage. And I never looked at facts. I do want to look at facts, and we'll do that later. But what I really want is protos. Did we look at this analyzers? Is this the one we looked at or no? Oh, this is the Java. I think I said I was going to ignore Java. Okay. So CXX. This is maybe for CMake, since we already saw Bazel, right? All right, let's look at some of the protos. Analysis Go proto, build info proto, the CXX Go proto. How about Bazel artifact selector? And V2. I'm guessing V2 obsoletes V1 maybe? Analysis service. We'll look at a few of these. Extraction, explorer, graph serving, and identifier. Why not? How about internal Go? Repo, etc., etc. A claim. I don't know what a claim is. I don't know what common is. File context. Identifier. Let's look at xref.proto too. Maybe we'll start at xref.proto. This file defines a cross-reference service interface based on the Kythe data. Tickets are Kythe URIs, like Kythe.io docs the URI spec. So I'm sure that you can HTTP. Where's the S? Google. I'm sure you can have, this point to like your local installation, right, of whatever your repo is. So they have some schema for URLs. Okay, it provides fast, read-only access to the Kythe cross-reference relationships. They generally include non-transitive single-step relations, like usage of a declaration. So if you have a variable and you use it, that's that's included as one relation. That's a single step. If you use a variable that uses another variable or whatever, that would be two steps. And I guess you'll have to traverse the graph to get that. Instantiation of a type, invocation of a function, direct inheritance or overrides, and so forth. Some transitive relations can be converted into cross-references by pre-computing a flattened representation of a transitive relation. The key design principles. All requests must be satisfied quickly. For example, in time proportional to the size of the return set. So linear, I guess it's saying, in the set size, in the size of the return, and the client should be able to batch related requests. And the client specifies exactly what facts should be returned. So the cross-ref service is an RPC service, like a gRPC service, that has three methods: decorations, cross-references, and documentation. So decorations returns an index of the nodes and edges associated with a particular file node. So I guess you give it a node, a file, and it returns you all the things. Or at least an index of the things. Cross-references returns the global references, definitions, declarations, callers, and related nodes of a set of requested nodes. Okay, so these are like all the things that have anything to do with like the function foo. And then documentation takes a set of tickets for semantic objects and returns documentations about them, including generated signatures and user-provided text. All right, cool. That's a really simple interface. Usually you have to work hard to get an interface this simple. I think it's only got 3 methods. Okay, so we have location. A location represents a single span of 0 or more contiguous bytes of a file or buffer. An empty location denotes the entirety of the referenced file or buffer. Okay, so this is like a slice into a file, it looks like. A ticket of the file is the location this location belongs to. The ticket is the URL? URI rather. Basically a file, I think. And it's or not basically a file. It can have different kinds. It could be a file, it could be a span of text. And what kind of location it is one of these things. If span, this is the represented span in the file, should be basically a beginning point and an end point. And then we're going to not use these things, reserved 3 and 4. And these are which type of snippets to return? None, or the default. So this is just to suppress, I guess, some output. I don't know why else you would have this enum here. And when you send a decoration request, you give it a location, a span kind, like I guess return the things within the span, only decorations contained within the window, or you can also say decorations that surround it. I don't know how they decide what surrounds it. And dirty buffer. Is your buffer dirty? If dirty buffer is non-empty, the results will be adjusted, patched to account for the regions of the specified file differing from the contents of the dirty buffer. I don't know which buffer this is. Oh, I guess you're sending in bytes, and this is... I guess this is maybe support for like you've changed your file, and so your file is newer than whatever is indexed, I guess, and you might like have added a variable or deleted one. And so you're like sending the part of the span or kind of like the diff between what is indexed and what you are working on. And it will, I guess, try to or possibly succeed in returning the information about all the stuff in the dirty buffer. Although I don't know how it will do that if you've changed a lot of other stuff. Maybe? I'm not quite sure. If true, return the encoded source text for the selected window. Source text is not affected by patching. And if true, return reference to edges whose source nodes are there, blah, 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 et cetera, et cetera. Okay, so this is cool. Let's see what else we got. That's cross references. Here's storage. Vname, here's Vname. Vname is a proto-representation of a vector name. It is not a version named, which is what DeepSeek tried to tell me. A strong name. We will also read about this in Wallabag. Vector name. A node is essentially a vector of its properties, leads to the naming scheme Kythe uses for nodes in its graph. A node can be uniquely identified relative to a universe of nodes by fixing a v-dimensional projection of the node's attributes that differs from all of the u minus n under the same projection. In other words, we can choose a name for n by picking a small basis of facts around the node and using the node's projection into the basis as its name. Okay, so we have facts about all the things. And fixing like a universe. The universe is like, I guess, I'm trying to think about this like on Google scale. So like, I don't know how often the code reindexing stuff works, but you can imagine that with as many employees as Google has and as large as their code base is, that at all times t the code index is out of date. And a universe, I think, is probably bound to a specific t in the sense that like Kythe, if you request information at 3:00 p.m. Pacific time exactly, then let's suppose that it at best knows about things that were known at 2:59. Then the universe, I think, is probably things that are only known at 2:59. And at that point, at 2:59, all of the nodes have a bunch of information about them, a bunch of attributes. And the name for the uniquely identified thing will be this vector, which is all of the attributes that are unique to it. according to some basis. And I don't know if basis is something that's chosen once and for all, or if basis changes with each update. I'm going to guess it's once and for all. All fields must be optional and must have default values. And by once and for all, I mean, I'm going to guess, just going out on a limb, that it's hard-coded in the code, and that as Kythe evolves, they might decide more things are relevant or fewer things are relevant. But I'm guessing they choose a well thought out basis that changes infrequently. All right, all fields must be optional. No field may ever be removed. If a field is deprecated, it may be renamed or marked with a comment, but it must not be deleted. New fields are always added to the end of the message. All fields must be strings and not messages. I guess by messages it means it can't be a proto message. One of the key principles is that we want as few field names as possible in a Vname. We're not trying to exhaust the possible dimensions along which a name could vary, but to find a minimal basis. Be conservative. Okay, that seems to support my well thought out theory. Okay, so what is a Vname? It has a language-specific signature assigned to the analyzer. For example, com.google.common collect lists new linked list of #1. I don't know what #1 is doing here, but I'm guessing that new linked list is a function. I'm wondering. I'm wondering if Kythe was originally written in Java, because this. I think I'm supposed to read this as a Java function name, some sort of constructor of a linked list, and that's its signature, including including basically all the package information. The corpus is the corpus this belongs to, for example, Kythe, Chromium, iMath, Koorosh, Adar, AOSP, etc. This is basically the project. The corpus label Kythe is reserved for internal use. A corpus-specific root label designating a subordinate collection within the corpus. If a corpus stores files in unrelated directory structures, for example, the root can be used to distinguish them. Okay, so this is some root information. It may also be used to distinguish virtual subgroups. Okay. And then path is a path structured label describing the location of this object relative to the corpus and the root. For example, the relative path. It must not start with a slash. It must be normalized to canonical form with no path elements like dot or dot dot. Okay, so this is basically like, where's the root? What is the relative path? Combining those should give you the absolute path in some sense. Corpus is I guess, basically like a string, a human readable identifier. The language will tell you what programming language it is. And they include Haskell, although I don't think Kythe supports Haskell. Maybe they do. And then other fields we may need in the future, but do not currently use. For example, branch, which you would use maybe for like a Git repo. Client, for a source-controlled client ID. Okay. And then we have a Vname mask, which is, I guess, just a Boolean for each of the things. And then we have an entry. An entry associates a fact with a graph object, node or edge. This is the primary unit of what? Of storage. Okay, so we're mainly storing the entries. We're going to store the Vname and the edge kind and the Vname target. So this is building up a graph. We have a source and a target, and then a type for the edge. We've also looked at some graph search, some graph databases. We looked at Neo4j for sure. I think we looked at another graph database, but this is a common idiom for storing graphs. And then we have a fact name and a fact value. And these look like they're basically metadata, like key value store stuff. And then we have entries is just a bunch of entries. And just to remind ourselves, we're in storage.proto, and then we have like things like read requests, write requests. And I think we're basically just storing these protos in level DB. Here's graph.proto. We have a graph service which has nodes and edges and probably some searchable stuff. edge set, etc., etc. Total edges by kind. We did see some graph, I think, Go files, and we didn't look into them, but that probably has some stuff like some standard graph search algorithms, maybe. Here's identifier.proto. Find request has an identifier, name, the corpus, the languages to look for, and find reply, and so forth. Okay. So I feel like I've seen most of the core stuff. I don't know what explore is. I feel like I can live without explore for now. Do I want to look at common? Point. A point has a byte offset, a line number, etc. Some diagnostic information, node information. Okay. I have to go soon. The only thing I feel pretty unsatisfied by at this point is understanding how really they get information from Bazel. Here's a Go file that I thought was a proto file. Wasn't there Bazel stuff here? Here's the Go proto. Here's a Go proto. Here's a build info. So let's try. Let's try Bazel Kythe. Kythe uses Bazel to build source code. I think maybe this is about building Kythe. Here's documentation about the Bazel C++ extractor. An extractor that builds index files from a Bazel-based project. Extractor builds a kzip file for each blah blah directory. Currently, Bazel doesn't have a convenient way to use Action Listener outside of a project. So first you need to add Action Listener to the root build file of the project. Extractor requires a vnames.json file that tells Extractor how to translate certain file paths. For example, in Bazel, project Java files are often stored in Java and Java test directory, but a path like java.com some domain foo.java should be extracted as com some domain foo.java with the Java prefix omitted. Okay, so this is, I guess, how Google stores their Java code, so that you know that some obnoxiously long path is going to follow. And they're saying that, like, if you have this convention, you don't want to have you don't want that Java prefix to be stored there because it's not part of the Java. That's not part of the package name. So that's a Bazel peculiarity, and you configure vnames.json to kind of have information about that. And this is calling experimental action listener extract cxx. So let's look at Bazel extract cxx. So I was looking at the Bazel directory, and then I think I skipped the extract cxx stuff because I thought it was maybe for CMake, but maybe that was where the stuff I really wanted was. Let's go back and look at maybe cxx or extractors/cxx. cxx/extractor. We have proto, test data, text proto build, command line utils, Bazel artifact.h. This looks more promising. We're now seeing some C, or rather C++. Bazel artifact reader, reader test, Bazel artifact selector, reader, cxx details, cxx extractor. I'm going to go through these quickly because I do have to go, but at least I know that they exist and that I'm not going mad. Extractor main, dump Bazel artifacts language.cc. I really meant to open the header. Some toolchain stuff. So this looks like something that's Bazel aware. It must be C++ aware because it's written in C++. There's some Objective-C stuff. So here's Bazel artifact.h. This is the header. We have some Bazel artifact file struct. It's got a local path and a URI. And we've got this equality operator. Some stuff declaring like a friend here. H combine. Some hash value thing that I guess we're combining hashes. We have abseil stringify. And so a Bazel artifact is, where did it go? So struct, a list of extracted compilation units and target which owns them. We have a label and a vector of Bazel artifact files. And that's pretty simple. And we've got some streaming stuff. Bazel artifact reader. This is now the C++ file. I don't know why I opened the CC file instead of the header. We've got an event reader. I don't really know what that is. Probably something that listens for events. Okay, so whatever this is doing some stuff. CXX details. We've got things like header, search info, the path, string path. Characteristic kind, whether files in this path are normal, system, or implicitly extern C headers. Angled dir index for things that are using like the system include thing with the angled brackets. A vector of paths. System prefixes. Okay. All right, this is looking like it's something that's supposed to understand C++. That's all good. And then the CXX extractor, we're importing all the things. Protobuf, gzip, strings, extractor, etc., etc. An opaque representation of the behavior of the preprocessor. The extractor collects logs of the observable behavior of the preprocessor called transcripts. Observable behavior includes operations like macro expansion or the selection of a branch during conditional compilation. We use these transcripts to determine whether a particular preprocessor context is observationally equivalent to another. For example, if a.h is used in two contexts, one in which another independent header has been included, and one in which it has not, those contexts should be equivalent modulo a.h. Okay. And then, I don't know what claiming.ad is, but this is some documentation, I guess. And so we've got some preprocessor transcripts. We've got a claim directive that's something about claiming resources. We've got some struct for source files. What is this about annotations? I don't know. Okay. So, compilation. Okay, so this looks all like pretty custom developed for Bazel and C++. I don't know if it's this involved also for Java. I don't know, for example, how hard it would be to add another language if you basically have to be a compiler developer for that language. But that's kind of a little bit what it's looking like so far. Good stable root. And I've been saying I do have to go. I'm kind of running late here, but I at least wanted to see some of this. Bazel main. This is, I guess, the main entry point. We have some flags here, command line flags. We're opening some files and so on and so forth. Verify proto versions. And we're going to initialize program and parse the command line with abseil. And we're getting like things like the configuration files, like the vname config, setting config outputs, and so on and so forth. Okay. Dump Bazel artifacts. So let's ask Gemini. So walk me through the process of how Kythe uses information from Bazel to build an index of a large mono repo. What information is Bazel making directly available that Kythe just consumes? And what information is Kythe computing itself that isn't directly observable in Bazel? How's that? What is this? What is this? Font error. The core idea is Kythe needs detailed information about how code is compiled to understand its semantics accurately. Bazel, being the build system, possesses exactly this information. Kythe hooks into the Bazel build process to extract information and then performs its own analysis to generate the semantic index. The primary mechanism to integrate with Bazel is Bazel aspects. Aspects are a powerful Bazel feature that allows you to attach additional logic and actions to existing build rules. Is this real? Aspects. Okay. We'll look at that. I'll read that on Wallabag. So you define a Kythe aspect for different languages. Run Bazel with the aspect, telling it to build your target, and also apply the Kythe aspect to the target and its transitive dependencies. Aspect traverses the build graph. So it seems like an aspect is basically, so Bazel is ultimately about building like a DAG, a directed acyclic graph of all the build stuff. And then it also does things like running GCC or Clang or whatever your compilers for your language with the appropriate arguments. But like the reason that Google built Bazel is to have a kind of global view of the graph structure. And it sounds like what aspects seem to be, based on not having read any of the documentation, is as you're walking the graph, you can do this kind of like traversal pattern where the aspect can gather information at appropriate points. Like the visitor pattern, maybe? The Kythe aspect traverses the dependency graph defined by Bazel for each relevant target. The aspect gets access to information about that target and the action Bazel plans to execute for it, like compilation. Then it extracts information. And then we have Kythe executor execution. So this is the, sorry, I said executor, but I meant extractor because I can't read. So it configures and triggers a Kythe extractor program. This extractor typically runs alongside or wraps the standard compiler like Java or Clang. It uses the compilation information gathered by the aspect to perform its task. So this is probably things like including, among other things, the thing that collects the preprocessor transcript that we saw. And then it generates kzip files. And then it indexes them. And then this is giving us more information about the stuff that Bazel makes directly available. And it includes the following: source files, dependencies, compilation commands. So I guess maybe what it's saying is that like if you're running Kythe alongside Bazel as an aspect, then the dependency information pretty much comes for free, although not at the level of like C tags, like variable names and who's using which dependency, who's using what, etc. Output locations, generated sources, and toolchain information. While Bazel provides know-how, blah, blah, Kythe computes the semantic information, including abstract syntax trees and semantic analysis. Kythe extractors invoke compilers or use compiler libraries like libtooling and Java plugins to parse the source code to perform deep semantic analysis. Bazel doesn't typically persist or expose the compiler's internal AST, etc. in symbol resolution. Determining precisely which definition an identifier refers to potentially across file or library boundaries. Bazel knows the dependencies, but Kythe resolves the specific symbols. Okay. And it does the Vname. So I'll say if you wanted to implement Kythe support for another language, like say Haskell, how would you need to know the language and Haskell compiler intimately to add Kythe support? Or does the Bazel, or is it mostly sufficient for the language already to have been integrated with Bazel? Well, that's that. Well, having the integration is very helpful and a significant advantage. It's not sufficient on its own. You would absolutely need intimate knowledge of Haskell and its primary compiler, GHC, to have effective support. Okay. That's what it seemed like based on its answer, but I just wanted to check. All right, so that's a little bit about Kythe. I feel a little bit sad inside that we do get a README, that we didn't see a lot of how the extraction worked, which was kind of mainly what I wanted to see. We have seen a lot of related stuff before, like we've looked at Clang, we've looked at did we look at Clang? We looked at LLVM. We've looked at GCC. We've looked at GHC. We've probably looked at other compilers. We've looked at other things that build source code and ASTs and stuff like that before. We have a sense of how all that goes. I would have liked to have seen more kind of how the integration went, because I saw a lot of Go code about building up things like Vnames and entries and storing them. And I saw some code about looking at Bazel files, but I don't really have a sense of how those two things build up. I do want to at least search for the word aspect to see if that's really a thing that they're doing. Yeah, extract CXX aspect. Okay, that's in tool build rules extra aspects. And we have Bazel artifact selector. I guess CXX, if I were to do this again, knowing what I know now, seems like spending a little bit more time in the CXX directory. And it's possible that this is one of the files that defines how the aspect works. But I'll leave things there. That's Kythe. I hope you enjoyed it. I enjoyed it. Thanks for joining me on this exploration of the treasure that is open source software. I'll see you next week. This is Ants Are Everywhere.